Hello everybody. Welcome to 12W12M series conducted by Econstruct Design Build Private Limited. As you know that this particular series has started almost 6 months back. Those who are new, actually, you can go back to the previous sessions. In the same name with the 12W12M series, actually the sessions are recorded and uploaded to our YouTube channel. This particular session is basically for the design as well as for the detailing. As you know that if you go to the site, it's not the ETABS or SAP or StatPro file goes to the site. It is generally the drawings, the 2D drawings, the printed drawings that goes to the site. Whether the size of the file, the hard copy is A0, A1, A2, A3, something like that. So, what are the technicalities that we required to see that in the drawings? Because that's a description, or I would say that that's a prescription that a site engineer or a project engineer need to see that we need what exactly we need to execute it on the site. Why I'm calling that as a prescription is, let's say for example, if you're a doctor, you're writing certain medicines, certain dose, so that the chemist will give the medicine as well as whatever the injections or whatever the doses are there, and will guide the patient that okay, with this particular prescription it will be okay. Many a times that certain doctors are writing in such a way that only certain chemists are able to read it, or the handwriting is not that proper, so that it's impossible for you to understand what basically they have written it. Can we use the similar kind of prescription in the civil engineering or in the structural engineering so that only particular site engineer would be able to execute it? No. It has to be crystal clear that any site engineer, project coordinator, or even the bar benders would be able to understand what exactly it has been written. So what kind of quality of the design, because this session would be design plus the certain the detailing stuff also will be taking it. What are the precautions as a civil engineer, as a structural engineer you need to take care so that the design is going to be perfect? Okay, so before making it too late, I would like to give you certain overview of certain sessions that we have conducted a little while ago. Alright, so let's get started. We have started in the month of September, in which we have seen various types of avenues and all, actually what are the jobs and what are the avenues are there. As you know that avenues which are related to the various different sectorial avenues, corporate sector, government sector, public sectors, as well as the corporate sector. Avenues which are related to the different building sectors such as residential, commercial, industrial, infrastructure, railways and all, actually. Subject-based avenues are also there, which are related. If you are very good into one of the subject, you can go to the geotechnical engineering, surveying, structural, environmental, transportation, and many other subject-based avenues are also available. Skill-based avenues are also there. If you are very good into public speaking, if you are having technical different skills, mathematical skills and various skills, you can pause the video and take care of certain skills that you might be having. Somebody will say cooking skills. Yes, if your site is there in the middle of the desert and if you are there in one of the contractor's site, actually you should know that how to take care of your body through a proper cooking. So different skills are definitely required for a civil engineer to adopt in order to live with the situation, any kind of situations that you might be facing on the site. Industry-based avenues like real estate sector is there, construction sector, interior designing, transportations, various different modes of the transportation and all. So we are having varied variety or software-based avenues. Okay, so let's say for example, which particular software that you are knowing, what kind of systems that you are walking through, that also is required. So what are the different softwares are there? Many people, they learn only the ETABS or Revit or AutoCAD. It doesn't work basically. Why? Because you require to know the series of softwares. Only in that case you will have an edge in the industry. So these are the software based. So let's say, for example, if you want to go through the BIM technology, or if you want to be BIM engineer, certain series of softwares, if you are knowing, that will be helpful to you. If you are there in the transportation or in the geotechnical or in structures, the series of softwares, if you are learning, that is comparatively better for you. So we have seen this in the month of September. In the October, architectural plan, structural plan, and basically how overall planning related things are there, how the architectural plan or structural plan or MEP plan starts, and what are the complications are there as a structural engineer, how basically you need to be coordinating with all other disciplines, and make sure that there are no issues on the site. So that is what we have seen that during the month of October. In the November, the grid-based systems also we have seen that the floor grid, plane grid, space frame, plane frame analysis and all. So we've gone a little deep into the subject to see that what system basically you need to follow. All right. So grids, different grids actually. What are the advantages are there to follow different grids, and as a structural engineer, how do you come across what kind of grid system for a particular project. In the month of December, what we have seen is different types of analysis. What are the different types of analysis we have seen? That let's say, for example, static, dynamic. In the linear static, non-linear static, as well as if you go to the dynamic, you are having linear dynamic and non-linear dynamic, and different types of analysis. And as a structural engineer, how basically you need to analyze the structure and make sure that the structural safety, stability is there within the permissible limits that are given in different code books. So 2021, when we have started, we have started with the post-processing techniques. It means that after the analysis, how to check certain things. Let's say, for example, the drifts, deflections, stress limits, or what are the load cases and the combinations are required to take care, how to see the deflections, how to see the bending moment diagram or shear force diagram at all. That's what we have seen that. Now we have come in the month of February. So in the month of February, as you know that structural design and detailing, this is a very important topic that we have come across. So what is structural designing? If you are very sure basically that what exactly imagine that you are a doctor and the patient is having this kind of disease or issues, so what kind of prescription basically you will be giving? That's a design. Okay, because the lacunas in the body actually will be filled up with certain maybe enzymes, proteins or chemicals or something actually which will make sure that the patient is perfect. So similarly, if you go to the structures, what kind of reinforcement you will be giving, what kind of thickness of the RCC element that you will be giving, or structural steel element that you will be giving, whether I section is okay, channel section is okay, or if it is a RCC beam, actually what should be the dimensions of that beam or a column or a shear wall for that sake, and what kind of reinforcement that you will be giving. So that is what actually the structural designing it means. If you go to the analysis, you require to give certain sizes of the columns, beams, so that the structural analysis is also perfect. So in order to show certain things, actually I would like to directly overview or give certain views actually of structural elements. What are the structural elements are there? Primarily, if you are speaking, the structural elements would be the slabs and beams. So you can see over here So you will see that the slabs and beams are there, which are basically the horizontal elements. What are the different types of slabs are there? One way, two way slabs, continuous slabs, flat slab, waffle slab, post tension slabs. Many types of precast slabs are also available. I'm not saying these are the only slabs. There are many types of Howdy slab is there. In the precast also there are various different options are there. So what I'm saying is how basically the slab is to be designed, which particular slab, waffle slab is to be used where. Waffle means actually, you will have the porous portion in between, so that it should not be entire big thick element which will increase the self-weight of the structure, so that certain portion actually will be removed, so that it will be lightweight, but you will get the effect of the big depth, so that moment of inertia would be increased. So these are certain techniques basically as a structural engineer you should know, that when to use the one-way slab, two-way slab, or different types of slabs, and as a structural engineer which kind of slab is more perfect. If you see the flat slabs, actually it is more perfect for the commercial buildings. For residential buildings, normal slab beam combination is okay. If you see this particular photograph, this is commercial building, so that from anywhere actually the HVAC systems, the ducting and all can be facilitated, so that it will not be creating problems for AC or HVAC systems. So this is related to the slabs. Now in case of beams, we are having the continuous beams, we are having the beams which are cantilever beams, or I'll just note it down over here so that you'll get to know a little bit more. So when it comes to the beams, what are the beams that are available? Let's say for example fixed beams, you are having continuous beams, you are having the simply supported beams, cantilever beams. Now these are basically the structural type. Fixed means actually you will be having, this is the fixed beam, so the bending moment and all will be something like this. So here at these portions actually there would be the shear walls or columns which will take care of this additional bending moment. This bending moment would be transferred from one element, horizontal element, to the vertical element. When it comes to the continuous beams, you will have column, something like that. If you are having simply supported beams, means something like this, it would be the case, right? So you know that the WL square by 8, so this particular element will not be able to take the bending action like that this particular element is taking. So these are basically, the cantilever is something like this. So whenever there is a action, actually you will have proportionate the bending moment, and even if you might have seen that the beams or something actually which you will be having is a little bit bigger depth. So what I'm trying to show you over here is these are basically based on the site conditions. I mean, whether it is a fixed means you are having shear wall here, or column here, so you'll be having the fixed element or continuous element and all. But these are basically based on the site or based on the type of analysis that we are doing it. But that's not something that we are only interested with, right? So the beam would be various different types of beams are there. Like let's say for example L beams are there, T beams are there. You are having the beams which are having the PT, post tension rods in it. PT would be used majorly for the place where the beam depth restrictions are there. Just few minutes back I have shown you one area, like let's say for example over here the depth of the beam is restricted imagine that you need to give the beam here instead of flat slab. So I would be giving the beam which is little bit less into depth, so that this PT strands can be moved, and obviously the there would not be any problem in moving the services, so that the clear height will be there and the interior would be done with the proper compositions. So are these only the types of beams? Varied variety of combinations, permutation and combinations of beams would be there. Sometimes the composite beams also will be there. I would like to just show you. There would be I section, and you will be having something like this. There are pros and cons. Basically, this would be the last resort I would be using. Why? Because I sections, again, you require certain shear studs or something like that. Because if you know the I section, it is, if you see the rebar will be a little torque will be there, the twist will be there. But when it comes to the I section, the surface is very, very plain, like your cheek. So there would be a bond problem, because if there is a RCC element here, okay, the bond between the steel and the concrete will not be that much good. So what we generally do is we give the shear studs. Okay, it's like bolting certain rough area elements on this, so that the concrete and steel will stick with each other properly. But is it the right way to do it, or what would be the better way? I would suggest that composite is something which you can give that as a last resort, even the PT also, because post tensioning something is like you absolutely do not know that over the period of time how the post tensioning losses that will occur. Okay, over the period of time means till the lifespan of the structure. Let's say, for example, Dombari Khel. For example, Dombari means actually this is a Indian word in which, let's say, a little boy or a girl is standing here on the rope, and you will be having some kind of tension creation element here, and there would be something like this. The deflection would be there, and this guy is balancing it something with the stick and all. That is basically the tension unit. Okay, so do you want your design to be like all the time it is balancing, try to struggle with the balancing and all? No. If you see the ancient ages structures, actually, you will see that there would be so many arcs. If you go to any of the temple, you will see the domes or arcs or something like that. Why? Because every element will be under compression. It's not a tension. Nobody likes tension, am I right? Tension creates the tension. Tension creates the cracking. Cracking creates, it will be deterioration. It will be, breaking phenomenon, to be very honest. So compression would be comparatively, preferred way. So that's the reason if you go to any mosque or a temple or a church or something, the lifespan of the structure would be comparatively higher. It is designed to be higher. Why? Because the generations and generations should go to the mosque. Generation and generation should go to a temple. It's not only the father and son, right? So that's the reason such kind of structures are designed for longevity. And longevity doesn't come that easily. You should be thinking that how to avoid the tension in the building. All right? So I hope you are getting actually what kind of structures that you are dealing with. You see if you go through a tunnel also, tunnel will have a dome on the top of that. Why? Because you don't want to create some kind of tension on the top. To be very honest, different planes, principal planes and the structures creates certain kind of tension compression zones also. Okay, so the kind of plate, shape is there. Let's say, for example, aircraft, or the kind of wings are there, the kind of aeroelastic bodies are there. That also creates certain patterns about the tension and all. So in the principal stresses and strains and the plate shapes also change or alters the kind of stresses that are going to exert on the structure. So this is about the types of beams and the slabs. If you preferred the kind of structures, which kind of project that you are dealing with, based on that actually you will be giving that kind of which is the most economical way of going through this is normal RC beam. So that's the reason the most economical way is preferred to be the normal RC beams. So you will be having RCC slabs and RCC beams and RCC columns. So that is one of the most economical way of going through it. So that's the reason many people are preferring that, but that's not the always case. If you come to the commercial, the things are different. If you come to the industrial, the things are completely different. And it's not only the residential areas that you are dealing with. There are varied variety of areas. As a structural engineer, you need to deal with it. All right. So let's go to the another part. So before entering into the another part, I would like to just show you a few things so that you'll get to know a few ideas about the structural slab systems. So I would like to just show you. Now this is basically the raft area. The raft is also slab, right? Just resting on the foundations. Sometimes somebody will say that raft is also the foundation. No. Raft is having, let's say for example over here, this is the, for example, yeah, if you come to this place, this is the raft, but this is basically the pedestal on that. So this will take care for the shear, because there is a column sitting on that, on the top of that. So if you see this, actually you will come to know that the top reinforcement is getting curtailed here, which is 40 times the diameter. The bottom steel also is going to be higher over here. Why it is like that is because to take care of because if you see the column, the forces coming on the top of this will create some kind of tension on this. Alright, so what kind of tension it would be, based on that the bottom reinforcement. If you see that this is a load, okay, let's say for example this is, you add this. So bottom portion will be always under tension, the top portion will be under compression. Alright, so depending upon that, you will give the rebars and all. Structural designing and the detailing should go hand in hand. What does that mean? You will give initially the thicknesses of the raft and the pedestal and all. Actually we call it as the arrangement study. Okay, so I'd like to just show you. So now this is very important. Please note it down properly. If you see any of the structural design, it is based on certain compulsive actions. We call it as the tripod shape of compulsion. 1, 2, 3. The first compulsive action is basically the chord. So even if the reinforcement is coming very feeble, quite less, code is saying that minimum reinforcement is this. There are various reasons are there related to the durability and many other things. So first compulsive action is code. The second compulsive action will be the design requirement. So what does that mean? So code is saying that minimum is, let's say if you take the column, the minimum percentage of column is 0.8, maximum you take it around 6%. 6 is too high. People are not going more than 4% generally, because it is too many rebars and all actually. So if you take the judgment, actually 4%, 0.8 to 4, so where do you lie in between? If you go to the British code, 0.4% is the minimum reinforcement that is required in the columns. If it is a shear wall, it is 0.25%. So what I'm saying is, the code decides that minimum how much percentage of rebar that is required to give. The design requirement means through the software or through the manual calculations or through the expertise, you will come to know that this is what it is required. The third compulsive action is the site. I would say that site common sense. Even if code says something else, design requirement is something else, but on the site it is not possible. Let's say, for example, you are giving 12 mm rebar in the columns, and on the top of the building, because of the sway action and all, you require 25 mm rebar. Can you practically give that? So it's a site common sense that you need to use it, that 12 mm cannot be connected with the 25 mm rebar. It's impossible. Or it is not practically possible because you cannot erect that rebar on the site. So there are 3 different compulsive actions that as a structural engineer you need to consider, so that your design would be perfect. Otherwise, no matter what kind of designer that you are there on the site engineer will take a toss on you that okay, yes sir, bata hai, like that. So you need to respect all the 3 things. Eventually you go to any part of the world, all right? To see that, we'll see certain drawings, so that you will come to know certain things what I'm trying to show you across. So let's go to the column drawings. Now let's say, for example, this is the column drawing. All right, so if you see that over here, these are certain rebars that you can see over here. So let's say, what is this? This is a column number. This is the level from foundation to the podium 1. So how many rebars are there? 20 bars of T 40 mm. So 40 mm rebar. How many numbers? 20 numbers. So you can see that all the 20 numbers are equally placed from all the sides. What is the size of the column? It is 750 by 1200. Now, is it only the rebars are required, the vertical rebars? No, you require horizontal rebars also, which we call it as the stirrups. So you can see that T8 at 250 center to center, 6 links, 1, 2, 3, 4, 5, and the 6th, the external one. So how the 6 links are there, that are also given here. So 1 like this, then like this, then like this. So like that, different types of rings are there. Now T8 at 250, is it there throughout? No, it would be there at certain span. If you know that, then it would be, let's say for example, this is the column or shear wall. You will have on the top and at the bottom of the surface, you will see that at this place and at this place, it will be either 100 mm or 150 mm. And the center of this column or the shear wall, you will have 250 mm. That is what it is given over here. That would be given in a different note. It depends upon the detailing of any particular structural engineer. Is this the right way of doing it? This is one of the way of doing it. Is there any better way to do that? Always yes. Please remember that there is no straightforward one route goes from point A to point B. Okay, if you see that the travel path, if you see from the geometry point of view, yes, there would be only shortest distance is always a straight line. Okay, so theoretically you will say, yes, you are right. There is only one line from point A to point B. But in the structural designing, since you need to go for different areas like tripod, for example. So based on the requirement, site requirement, code requirement, design requirement, the things matters, it will change. It means that from point A to point B, there is not one route, there will be multiple different routes are there. So structural engineer will opt for a particular route or will opt for a particular design for that matter. So if you see this design, is this a perfect design? I would say yes, merely perfect. But is there any better way to do it? If I see that 40 rebar is there, if you are connecting with tiny little thread of 8 I don't think it is really going to hold, right? So I would prefer at least 12 or 10 8 will not be able to hold 40 rebar. Am I right? I mean, this is my personal finding, right? You can comment your suggestion in the description box below. All right, so this is one of the correction. In 20 I think this is perfect, 8 For 20 8 is okay, completely okay. It will hold it. But for 40 I really doubt. All right, so this is what I personally feel. All right, so this is one of the design. So we have seen that for one particular column at one level, as you go up. So 40 bar here, can we give 30 40 rebar and 20 numbers are there over here. If you go up, can I give this 230 by 600 column? No. So there are certain rules about the sizes also. These are not the rules of the code. These are not rules of the design requirement. These are the rules about the site. All right. So 750 by 1200 would be required. And yes, 20 numbers of 40 are required. If you go up 20, 40. Now, as you go a little up over here 24 numbers of T40. Oops, can we really give that? Since you know that there is a transfer girder, then it is possible, otherwise it is impossible. You cannot increase the number of rebars that suddenly. There is a transfer girder. Transfer girder means there would be a very thick slab would be there. That would be generated. Now I'll show you the design also, or the model also, so that you will come to know what I'm saying. So this is the model. Now if you go different floors, so this is the transfer girder. If you go down, the things are a little different. If you go up, the things are a little different. So this is the column. As you go down, you will see that this column size is smaller. I hope you are getting what I'm saying. Okay, so I'll just select this portion and I'll select just this portion and I'll just go to this place and show you in the 3D. And in this 3D, I would like to show you in the extrusion view. Now I hope you are getting what I'm saying. So in this case, you will see the column size is comparatively bigger. At the lower floor, it is a little smaller. Why? Because this is resting on the transfer girder. So this is at one place, this is at another place. Alright, at the lower floor also the size and all are changing. I'll just remove the grid systems so that you can see it better. Yeah, now it is perfect. Alright, so such kind of decisions are required. I'm saying that whatever I'm showing you, that okay, the rule is, as per the rule, you cannot increase the number of rebars unless and until there is a strict requirement from the design point of view or from the site point of view. Understood? All other places, if you see that the number of rebars 22 T40, 22 T40, 22 T40, then 20 T32 and 16 T20. If you see that some other place, so let's say for example over here, 14 numbers of T16, 14 numbers of T20 if you come down, because the load has increased and the size 800 by 600, 800 by 600, 800 by 600, 800 by 600. So all are almost 800 by 600. But if you see that this is 25, 14T25, 14T20, and then if you go up 14T16. So 16 mm is the diameter of the bar and 14 is the number of rebars. As you go up, the number of rebars are remaining same, but the diameter of the rebar is getting reduced. Sometimes the number of rebars also eventually you can reduce. It depends upon the designer. That's you, which kind of composition that you are preferring. Can you give 15 number of T16? So one rebar, where you will give it? The center of the column? I still remember at one place, I don't want to take the name of the company or something, when I was there in Dubai, at one place, I have seen that one of the doctorate person has given the one rebar at the center of the column. I said something is wrong over here. And over the period of time, he has understood that yes, there is something really wrong over there. So theoretically, if you are very, very good, practically you are not. You cannot give the center of the column one rebar. Why? Because if you see the action, so let's say for example, I'll just draw a certain sketch here. Let's say for example, one column or something is over here. If you see the stresses, it will be going through like this. So obviously the center of the rebar will be having very less amount of stress. It is impossible, it's not practically feasible to give it is useless to give to give the rebar at the center of this. Instead of that, if you give the rebar at the edge where the higher stress values are there, that would be more preferred. Alright, so that's how actually certain common sense you need to use, certain structural sense you need to deal with it, and depending upon that actually you need to design the columns. Few more practicalities I would like to show you. So let's see, I will go to the all structures and I'll just go to one of the elevation. Yeah, okay. So let's say for example over here, if I am designing, so let's say reinforcement rebars. So this is the percentage of rebars that is there, and I would like to give the rebar reinforcement also. So depending upon, now currently the reinforcement rebar is over here is 11,520. That is changing to 4,500. Here also 4,500. So that is square rebar. So how are you going to give the rebars exactly? What is the area of one rebar and how many number of rebars are required? Okay, and similarly to the beams also, as you know that over here you require higher reinforcement at the top and bottom also. Here also you required higher reinforcement on the top and bottom also. Here you require comparatively less top and bottom. Why? Because the diagram, the shear force bending moment diagram will be little different. How it would be, I will like to show you. If you go to the, I'd like to give it to the envelope. Yeah, you can see that the maximum bending moment would be there at the edges, whereas at the center of the spans you will see that the bending moment is comparatively quite less. So that's the reason the design changes will come. Understood? So this is how actually you need to design the slabs, beams and the columns. When it comes to the slabs, In the slabs, you will see the bending moment of the slab also. So let's say, for example, here is the envelope. How much is the bending moment coming here across? So depending upon that, MU upon BD square, and you will give the reinforcement details for the slab as well. Now, if you come to the slab, you will see the details over here. M11, M22, M12. What is M11? M11 is the bending moment along the 11 axis. M22 is the bending moment along the 22 axis, and M12 is the bending moment along M12 axis. What is 1 2 1 2 1 2 I'm saying? So let's see that. So if you go here, you will see that there are local axis coordinates for the shell. So we call it as one mantra. There are so many mantras are there in the Hindu religion. So mantra in the structural engineering, what is the mantra is RGB, RGB, RGB. That's a mantra we generally tell it to the structural engineers. Not RCB, okay? RG, what is R? R is the red color, G is the green color, and this little blue is there. Why? Because if you go to the 3D, wow, you will see this blue color which is popping up perpendicular to the slab, correct? So R is the red color, RGB. R is 1, G is 2, B is blue, which is 3. Alright. So whenever the bending moment going along the 1 axis, so M11 is the bending moment along the 1 axis. So whenever you are taking M11, you will see that the bending moment is going along the 1 axis, and the reinforcement rebar also will go along the 1 axis. Correct. So let's say if you are having the rebars, the bending moment like this, you will give the rebar in that direction only to straighten it, make it tight. Correct, no? So that it doesn't get bended or it doesn't get deflected. Similarly, in the 2 direction, G is the 2 direction. So in this direction, how you will give the rebar? Because you will take the bending moment along the 2 direction. And somebody will say, what is 1 2? 1 2 is the tangential bending moment. So it is the twisting bending moment. So you will take care of this twisting bending moment also. Alright. So so if you see the slab, for that matter, this is a raft which is also a part of the slab only. So you will see the bending moment in this direction, in the other direction, as well as the twisting action. So depending upon that, you will give the rebars. Now, since I'm telling you the slab, I'll just show you the slab detailing. So shear walls also I'll show you, and I would like to show you the typical details, floor details. Yeah, so this is basically the slab design. So you can see that the slab design is there: short span, long span, top steel, this is the bottom steel, and you can see the slab details and all are given here. Now, one is the physical arrangement. Let's talk about it. Physical arrangement, you can see that beam lines are there. Certain lines are dotted lines because you cannot see the beam which is below the slab. But I can see this beam. Why I can see this beam? Because there is a void here. So I can see it with the naked eyes. Alright, can I see this line? No. But this line is there? Yes. This is the beam line. But extra small projection of the slab is there. There is a sunken slab of 600 mm. Okay, because waterproofing is required sometimes. This is the slab. This is one line this is the straight line. Why? Because this is a sunken area, so I can see the edge of the beam. But here I can't see the edge of the beam because there is no sunk. So each line, what I'm trying to say is this is a detailing session. Please understand, guys. In the detailing section, each line carries a lot of importance. Okay, just AutoCAD, you can't draw this. You require a lot of sense, believe me. Okay, and that is what actually we generally wanting you guys to get trained for. So this one is basically, you will see that shear wall, you can see the straight line. This also is a straight line with the cross mark, means you should not be casting the slab here. Otherwise it will get casted on the side. Then you need to break it, then you need to remove it, it will deteriorate because of the vibration, core cutting and all. Why all this mess? Just make sure that there is no slab here during the casting by itself. Similarly here, okay, this line is a straight line. Why? Because it will be seen the edge of the beam if you go to the side. Generally, if you ask me, structural, this is very important. If you see the architectural plan, the cutting plane will be at the the window sill level. The cutting plane will be at the window sill level. But if you see the structural plan, the cutting plane would be at the slab level, top of the slab level. Okay, so this is how actually the design, the detailing is to be made. What is this? This is basically the door opening. Understood? So all these markups are given, and what is the size of this? You need to find out from the architectural plan to give this particular size, so that at the time of casting only you will come to know this. Alright, so each line, each point actually you will get to know many things. At this place, what the hell is this? This column is below stopping, and the another column, this column is basically starting from this edge. So you can see that the edge of, this is the edge of the building, will remain same. Understood? Okay, this is the column number, beam number, slab number, bracket number. Okay, so all these markups are given in the drawings. What is this? This is the sunken area. Understood? So these are all structural detailing is what you need to learn across. Now let's go to another topic. Now we have seen that the structural slab, beams and columns. Now let's see the shear walls also. Now coming to the shear walls, what does shear wall mean? Structurally, if you see the shear walls, I think seeing is believing. So let's see that first. I would like to just rotate it. Give me a sec. Yeah. So if you go here, this is the shear wall detailing. Alright. Now this is C22/C25. What does that mean? This is a column. What is the reinforcement of the column? It's there in the column drawing, not here. Understood? Then what is it here? It is only the shear walls that I am giving to you. So this is, you can see that this is these are the links that I am going to give over here. So let's see how to read this. This is the shear wall number which is coming across this. This is the shear wall number which is SW8 and similar to SW11 which is here. Then T8 at 200, which is the horizontal rebars, but vertical rebars is 18 numbers of T12. So the horizontal, which is links, are T8 at 200. These are the links. Okay, and horizontal rebar is also T8 at 200. Horizontal means these two lines is the horizontal. Links is these are the links. Understood? So this is how, this is up to the scale, as per the scale as 1:25. So like that you will see many other areas and detailing requirements and all actually which are required for depending upon the shear wall. If the shear wall is little bit bigger, you will see that 16 mm rod bar is used and 8 mm is used over here. Understood? So this is the detailing of the shear wall. Understood? Yeah. So I'm sorry. So we have seen the varied variety of detailing areas, which is the shear walls and all. You can see that when it comes to the shear walls, actually there is a linking element between the two. There are certain areas we call it as the horizontal element, vertical element, and certain areas you will see that the interaction between the two elements. Now this is a little advanced actually. What is this? This is basically the column portion. This is the beam portion of the shear wall, and this is also the column portion of the shear wall. Now what the heck is this? Let's look into it carefully. Now, whenever there is the action which we call it as the horizontal action or a bending action, you will see that this particular portion will be coming under the compression. This particular portion will be coming under the tension. So this zone we call it as the column. This zone is also known as column, or will be detailed as a column, and this zone is the connecting element which we call it as the beam. So it is a column here, and a beam here. In the structural shear wall systems, the name is boundary wall or a boundary zone element. Okay, so you will have a little bit confinement reinforcement here. Confinement means too much of, I mean, if you ask me the detail of this, if this is the case, I will give a little bit more shear wall, I mean the vertical columns here, and these columns will be lighter columns, means lesser number of rebars will be there, and this is going like this straight, for example. So at this place you will see the something like this, and at this place you will have only the horizontal rebars like this, and at some place you will have only the connecting elements. So this portion would be either this portion or this portion, which we call it as the boundary zone element. And so this is how actually the structural detailing is required to be done. Now if you go to the model, I'll take any of the, so let's say any of the elevations, I'll take it. Okay, so at this place I'll show you the pier numbering. And the spandrel numbering. So here you can see that, I'll just go to the plan. Yes, this is the pier number, which is basically the column. This is the spandrel number, which is basically the beam connecting element, and this is also the pier number. This is also the spandrel number. So if you go to this place, I would like to just remove this. You will see that what is pier and what is spandrel. So shear walls, this is shear wall, this is also shear wall, this is also shear wall, but this is a dumbbell shaped columns are there in between, so that I can give this as a column, which is PC1, PC21. This is a shear wall, this is a shear wall, this is also the dumbbell shaped columns are there. So, and where is the spandrel? So if you know that at certain places there is a opening given. Yeah, see here, this is the place where the opening is given. So above the opening there has to be a beam, so that would be the spandrel beam. All other places it will be the shear wall. This is a shear wall, this is a shear wall, this is a shear wall. So this is how actually the structural arrangement we need to do it in case of the shear wall system. Okay, there is a very big literatures and the theory is available. You can just search it across how to give the pier labeling and all. There are basically 3 to 4 different idealizations are there, which is shear based idealization, pier based idealization, or bending idealization. So depending upon that, the pier labeling has to be done and the designing has to be done. All right. So this is how about the shear wall detailing is what is required. So we have taken care of the slabs, beams, columns, shear walls, and also the raft place I have tried to show you. All right. So this is how the structural detailing is required to be done. Is it only the raft is, if you come to the foundations, the foundation is not at all, many people they see that foundation is just the one way, two way shear or punching shear. If you take and the bending take care, actually everything is okay. No, it is absolutely not like that. Why? Because if you see this photograph, you will see that there is a retaining wall is there. Okay. Yes, there are piles. These are the piles. Okay, so there would be a raft, there will be piles, there will be a retaining wall, there will be the shoring piles. Many other things would be there over here. And there is a individual pile cap and there is a group pile cap. So always remember, guys, that foundation is not the element design, it is a system design. Come on, say it with me. Foundation is not a element design, it is a system design. What kind of system is required to make my building stable? Isolated footing is one type of system. Combined footing is another type of system. Sometimes you require isolated plus combined. Sometimes you require raft plus piles. Sometimes you require pile plus raft. Sometimes you require only the pile foundations with the pile cap on the top of that. Or you require mixed combinations like as I'm showing you right away. You require the retaining wall. Sometimes there is a basement, like in this case there is a basement. So you will see that at this place you need to go deep down into the ground so that you can make this kind of things possible. So what are the precautions you required for this? So there are raft means you will have the area springs and then you will have the point springs. So many things would be there when it comes to the raft as a system. So please consider, for God's sake, foundation is not an element, it's a system. So what kind of system that you are going to give, what kind of precautionary things that you need to do, it is a very separate topic altogether. Alright, and depending upon that, you need to design the system and model it, analyze it and design it. If you are having different type of system, what is the behavior of the superstructure? We call it as the soil structure interaction. Understood? It means that if you are wearing a chappal, a slipper, how are you feeling? If you are wearing a shoes, how are you feeling? If you are holding, if you go to the place where skiing is done, when you go to the Himalayan ranges or snowfall is there. So how are you feeling? So what I'm trying to tell you is different types of shoes are there. Depending upon that, you are feeling different feeling will be there. Similarly, if you go to the foundations and all, actually you will see that same things you will be getting it, or same behavior you will understand it. So foundation, meaning to tell you, foundation is not at all the element design, it is always the system design. Similarly, if you go to the superstructure, whether you want to go for slab beam system, whether you want to go for the couple system when it comes to the formwork also you require some kind of systems. Okay, so always there are varied variety of systems are there. Okay, if you are using R value 4, then there is a different system. Whether it is, for example, the dual system is there, shear wall system is there, RCC, or if you take the framing system is there. So varied variety of systems are there when you are talking only about the R value. Okay, which we call it as the earthquake resistance element. All right. So what kind of system that you are following, depending upon that how the analysis is happening, depending upon that how the design results you are getting, and depending upon that how the detailing is to be carried out. Everything has to be consistent. Please, for God's sake, do not learn in bits and pieces. Unfortunately, during the curriculum, it has been trained in such a way that this is simply supported beam, continuous beam, portal frame analysis. Matter is over. Structural analysis 1, structural analysis 2. Chapter is over. Now you come to the design part. Then you will get directly ready-made bending moment diagram, and you just take the MU upon BD square and start designing it. But if you change the section of the element, analysis is going to change. If you change the system, actually the load path is going to change. So that kind of thing is not available basically during the curriculum. So I would request each one of the professors who are watching, actually, please give the holistic approach to your students so that they will learn the holistically how the behavior is happening, of the structural behavior. It means that, for example, if you are teaching bits and pieces, you know, ये नाक का डॉक्टर है, ये कान का, I mean, any doctor is there who is ENT specialist, somebody is there eye specialist, somebody is there actually the the heart specialist, kidney specialist. But as a holistically one body, actually it is getting synchronized with every organ. So you need to see as a holistic body, not as just the bits and pieces of organs. So similarly, in the structural engineering also, how it is getting correlated. Otherwise, you will not be a good doctor eventually. All right? If you are not watching it through the holistic person. All right? So this is how actually we generally help the guys to train, to get themselves learned about the different types of systems, different types of analysis and design and the detailing. I'm sure that in this particular session of T12 W12M series, you have learned quite a lot of things. I'm not sure this is the end of it. It's a sea of knowledge that you will be getting through this kind of web series. So please stay tuned and please make sure that you subscribe to this channel. Why? Because you will come to know many such kind of things over the period of time. All right, so thank you very much for attending this, and those who really want to participate in this kind of session, you can just watch the videos. If you really want to have a certification and all, your college has to be registered to our company portal. Okay, so how to make the registrations and all, actually there is a number given in the description box, or it is there on our website also. You can contact to that through the WhatsApp. We'll give you the forms and all. There is administrative procedure is there. It's a simple process. It's just one form filling. But the college coordinator or college professors or HODs, they need to talk to our management before doing this. All right. So I hope you guys have learned quite a lot of things through this session. Thank you very much for attending and giving your time. Bye bye.